Hi students, welcome to Narayan P College online classes. Now my name is Somshekar, Mathematics faculty. Today we start a new chapter, sets. Already we learned some basics in school level, 10th class. What is a set, what are different type of sets, how to find this is set or not. Different concepts you learn in some basics in school level. Now we learn some more concepts in first phase. Now first of all, what is the meaning of set? A set means the collection of well-defined objects, members or elements. Set is called the collection of well-defined objects is called set. The set of things, generally if you take a set of rivers in the India, if you take the set of benches in a room, the set of students in a classroom. These are the general examples for set. You can take anything in the living world, you can take that all are belongs to which one? Set. The meaning you have to understand this collection of well-defined objects. Okay? Now, generally, these objects are elements or members. All are synonymous terms. Synonymous terms. Same meaning only with. Synonym terms of objects if you call or elements or members. These all are synonymous terms of the general notation. Meaning will get same only in this. Now when coming to generally, we are defining or denoting the sets with only capital letters, capital alphabetical letters. Sets are denoted by only capital letters. Capital letters mean that is some A, B, C, D, X, Y, different etc. And what the elements are the objects and the elements. Objects are denoted by with small letters. Small letters means that is like small a, b, c, d, e, f, s, and so on. And just simple meaning of set. General example for set means anything in the living world, set of balls in a bag. It's all are simple examples for set. Now objects, elements, numbers are synonym terms of the general meaning. You get same meaning of these three terms. Sets are denoted by only with capital letters and objects are denoted by with small letters. For example, how to identify the particular element is in the set or belongs to the set, is a part of the set. Now, for example, if an element small a is element of set A, then how to write this one? Then we can write this. Then small a is belongs to A. You can say that what? A is belongs to set A. This element A is belongs to set A. This symbol what meaning it gives? Actual name of this is epsilon. Simple meaning of this one, you can take the condition wise epsilon symbol. And what is the meaning of this is belongs to. It's a Greek word symbol, Greek symbol, epsilon. This meaning what it gives means belongs to the meaning. So when any element A is an element of set A or belongs to set A, then we can say that what here A is belongs to set A. For example, if A is not belongs to set A, then we can write A is not belongs to A. This symbol meaning what here? Only epsilon if you take, there is belongs to meaning. This is symbol for not belongs to, does not belongs to. Here what? Not this meaning. Does not belongs to. This meaning of epsilon understood? Any element is a part of or element of set means we can write that element is belongs to the set. Not belongs to means like this. A is not belongs to set A. This is a simple how to identify that element is belongs to or is part of the set or not part of the set. We can define like this. Now, for example, can I take a set like this? I am taking this collection means I take empty places. Generally, simple example I do 2, 3, 4, 5. You want to check the element A is a set. For example, element 3 is belongs to or not. Clearly, 3 is belongs to A. 6 is a set or is part of the set? No. 6 if you take 6 is not belongs to set A. 2, 3, 4, 5 is all are part of set A only. But 6 is not an element in set A. That's why 3 is belongs to A, but 6 is not belongs to A. This is the symbols we are using in sets concept. Okay. Now, what is a representation of set? Okay, simply you can say that methods of representation of sets. What are the methods? Or we have forms generally we call it. In that there is the first one, set builder form. Second one, roster form. These are the two forms. One is set builder form, another one is a roster form. We will discuss what is the meaning of these two. Now, in the first one, the methods of representation of set. First one is set builder form. In this form, all the elements of set possesses with a single property. That means all the elements we are expressing with this common formula or common property. That is called a set builder form. All the elements of set in this form, all the elements of set possess with a common property or common expression or common formula. That formula will give all the elements of the set. Okay. Now this is a simple definition of set builder form. All the elements of set possess with a common property is called a set builder form. For example, set A is given if A is set of all odd natural numbers. generally what you take 1, 3, 5, 7, 9 like that. But here we are writing with a common property. How do you write? The element is x. That x is clearly is odd natural number such that the symbol meaning is such that equal to 2 into n is a even number. 2n plus 1 gives which number? Odd number. If you want x value means you take minus also. Because we need the odd natural numbers from 1 onwards. If you take plus means you get from 3 onwards. First m 1 to what will you get? 2 into 1, 2 minus 1. 1 will get. If you take 2, 2 2s are 4 minus 1, 3 will get. So a common property what I am taking here 2n minus 1 where n is belongs to capital N. This is which one? Natural numbers. Set of natural numbers. I had expressed clearly with common property. This single property will give the set of elements x. What is x here? 2n minus 1. What is n here? Natural number. If you substitute one value, you will get set of all odd natural numbers. So this is a simple definition of set builder form. Coming to second one, roster form. Have another name also, tabular form also. Roster form or tabular form. This is very simple. All the elements of set expressed in between braces, empty braces, separate each element with the commas. In this form, all the elements of set taking in between the braces. Braces means this is the braces. Flower brackets we call in between braces and separate with commas. Separate with commas. Is called a roster form or tabular form. Simple example if we take. Set A is all positive integers. All positive integers. Now here, this one you have to express in roster form what I said. All the elements of set taking in between the braces and separate with commas. Now set A, you want to take in between the braces, separate each element with which one? Commas. Now all positive integers. Which are the positive integers? 1, 2, 3, 4, 5. Generally. So what will I here? 1 comma, 2 comma, 3 comma, 4 comma, 5 comma, and so on you get. What I taken? I taken the set of all elements in between the braces and separated with commas. This is our concept of roster form or tabular form. Here we need to write in the set builder form. All the elements we need to write with common property, a common formula. That formula will give us all possible elements in the given set. This is a set builder form and this is a roster form or tabular form. Now few symbols we are using in mathematics, the collection of numbers. For example, set of natural numbers, whole numbers, integers, real numbers, rational numbers, this all are there. Now, first, what is the meaning of capital N? Capital N gives set of all natural numbers. Natural numbers means 1, 2, 3, 4, 5 to infinity. Next, W gives set of all whole numbers. Whole numbers means from where to where? 0, 1, 2, 3 and so on. Natural numbers means 1, 2, 3, 4, 5 and so on. Next, Z. Z gives set of all integers. Sometimes in the case of Z they will take I also 0. Okay? Then what are the integers? 0, 1, 2, 3 and so on up to infinity, plus infinity. Negative side -1, -2, -3 and so on up to minus infinity. These are the integers. Next, if we take Z plus. Z plus means set of all positive integers. Set of all positive integers. Positive integers means nothing but natural numbers only. 1, 2, 3, 4 and so on up to infinity. Okay. Next we will take R, capital R. Capital R means set of all real numbers. Every number is part of real number. Natural number, whole numbers, integers, positive integers, rational, irrational. Every number is part of real numbers only. This will exist from minus infinity to plus infinity. In that every value is including in the real numbers. Next, Q. Q is nothing but set of rational numbers. Rational numbers means the number in the form P by Q form, where Q is not equal to 0. Now to write it simple. Any number, this P by Q form we can express. 0 is also rational number. 1 you can write 1 by 1. 2 you can write 2 by 1 like that. 3 you can write 3 by 1 like that. Any number in between this, so many you will get. Simple meaning is what here? The expression you can take the number in the form of P by Q, where Q is really not equal to 0, but all numbers we call as rational numbers. Clear? At least remember these symbols. You can understand, because some places we will solve symbols in mathematics. Okay? Now we will discuss few examples related to set value form and roster form. Example 1. Write the solution set. Write the solution set of the equation x square plus x minus 2 equal to 0 in roster form. Roster you can take with here, but without here also you can take no problem. Spelling. Roster form. Now roster form already what I said, the set of all elements expressed in between empty braces and separate each element with commas. Now this is the equation is given, x square plus x minus 2 equal to 0. It's clearly quadratic equation. Factors, we need to factorize this. X square into minus, that is minus 2x square, minus 2 factors what I can take, 2x minus x. Minus 2 equal to 0. Product will give minus 2x square, sum will get x only. That's why these are the factors. In this first two elements I can take x is common, you get x plus 2. In this 2 I will take minus 1 is common, x plus 2 equal to 0. Take x plus 2 is common, what remaining? X minus 1 equal to 0. X plus 2 equal to 0. Our next one is x minus 1 equal to 0. x is equal to minus 2, x is equal to 1. These are the two elements we got for the given equation. Now we can write a set as a solution set. These two are the solutions. Solution set will be written in the form of roster form. In empty places, separating these two elements with commas. Minus 2, comma 1. It's very simple. Okay. Next, second question. Question number 2. Write the set of all bracket x such that x is a positive integer and x square is less than 40 in the roster form. In the roster form. We need to find it. Now coming to the solution. What the set is given? X is a positive integer and x square is less than 40. Take the first condition, x square is less than 40. X square is less than 40 means what value should we get in between that we need to identify. Exactly, notations. Now, x square minus 40 is less than 0. We can't take this one perfect square, that's why we take a square that side is root 40 will get. Root 40 means approximately how much you will get here? Root 36 is 6 now. So how much you will get exactly? Approximate value will get in between is less than some 6 point something will get. 6.20 something will get. So x square is less than some 6 point here x square is less than 40, take square, the set will become square root. X is less than root 40. What will get here? X is less than 6.32. Less than 6.32, 0.32 is not a positive integer. 6 also part of that. That's why positive integers means you can take 1, 2, 3, 4, 5 up to 6 only. That's why the set what you get here in the form of roster form. What are the possible elements you get? 1, 2, 3, 4, 5 and 6. These are the possible elements in roster form for the given condition. X is a positive integer and the condition what is given x is less than 40. This is the solution for this second question. See next question. Write the set A, set of 1, 4, 9, 16, 25 and so on in set builder form. Set builder form concept what? All the elements of set possess with common formula property. Now how to write this one? Yes, observing this every value set A having like this 1 square, 2 square, 9 you can write 3 square, 4 square, 5 square and so on is there. Power is square only common 2, but base whatever is there 1, 2, 3, 4, 5. These are which numbers? Natural numbers. That's why we can write this one in this form. The element is x such that what is an x? How to get? X is equal to natural number square. Why? 1 square, 2 square, 3 square, 4 square, 5 square. Like that is there. That's why where n is belongs to natural number. This natural number substitute 1 will get 1 square, 2 substitute 2 square, 3 square, 4 square, 5 square, 6 square. Like that we get every element in the set. Okay. Next, question number 4. Write the set of 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7 in the set builder form. This given set will be written in the set builder form. Now the value, how to write this one? Observe 1 by 1 plus 1, 2 by 2 plus 1, 3 by 3 plus 1 is 4 only, like 4 by, if you take a n, is up plus 1 you will get it, n plus 1 you will get it. But n is up to where? Only 6. Okay. Now, how to write this one set? I'll assume that this is a set. 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7. It is write in the set builder form. This is there in lots of form. Okay? The element x, that x is equal to numerator will write n, denominator getting n plus 1. But n is lying between 1 to 6. So n value in between 1 to 6 only. Only we are taking positive values and it is clearly natural number also. N is belongs to capital N. 1 to 6 means you will get 0.1, 1.2, 1.3, that also you get. But which is that number? Clearly natural number. You get decimal numbers also in between. That's why 1 to 6 will be take 1, 2, 3, 4, 5, 6. But it's clear which number? Natural number. Substitute 1 here, 1 by 1 plus 1, you get 1 by 2. Take n is 2 by 2 plus 1 is 2 by 3. Like that we get up to 6 by 7. This is a simple expression of set builder form. Next, exercise 1.1. In this first question, which of the following are sets? Justify your answer. In this first one, the collection of all months, all the months of a year beginning with the letter J. Beginning with the letter J. We need to identify this is set or not. Now, clearly, collection of months clearly in the year is 12 only. In the starting with the letter with J only, we have well defined is there. For example, possible or what? January. Next, June you will get. Next, July. In other is there with J starting only these three, but it's clearly well defined. Well defined months. It's clear which one is known. It's not changing by person. In the 12 months, starting letter with J only have only 3. It's clearly set only. That's why is a set. Coming to next second question, the collection of 10 most talented writers of India. Now, what is the given statement? Collection of 10 most talented writers of India. This is not a set. What is the reason? The most talented writers of India, the person to person, the opinion will be changes. It's not well defined always. Because the person to person, for one person like one writer, but the other person not like that person. Is according to his knowledge, he is not the talented writer. That's why this is not a set. Reason? The collection of what are given 10 most talented writers, as a person by person opinion changes. It is not well defined. Next, third one. A team of 11 best cricket batsmen of the world. Here also same meaning. The batsmen are not the team best cricket batsmen. Now, for example, for me, Kohli is the best batsman. For others, Dhoni is the best. Like that, it is not person to person opinion will be changes. It is not well defined always. For one person, Raina is good batsman. For others, not. That's why this is also not a set. Coming to next, the collection of all boys in your class. It is defined because as per your class, how many are will be there? That's defined only clearly. That's why this is clearly a set. Next, coming to fifth one, the collection of all natural numbers less than 100. Less than 100 natural numbers defined only 1, 2, 3, 4, 5 up to 99. This is also clearly a set only. Next, a collection of novels written by the writer Munshi Premchand. Now, if a particular person is given, clearly how many written the novels? Clear, that's why this collection of defined objects will be there. That's why this is set only. Next, coming to the last one, the collection of the even integers. Which of the even integers? If we take 2, 4, 6, 8. This also defined only. That's why this also is set. Coming to two more questions are there in this first one. Now next, eighth one, sub question. The collection of questions in this chapter clearly is defined because clearly they will give the well defined questions only they will give. That's why this is clearly a set. Coming to next, a collection of most dangerous animals of the world. Here the person to person will be changes. For example, for one person dog is a dangerous animal. For others, tiger, lion, like that. That's why person to person this opinion will be changed, is not well defined. Relative set means that number is for every person is set. That collection of objects clearly well defined for every person to person. That's why, but this is not a set because the person to person, the most dangerous animal will be changes. That's why it is not a set. Not a set. Coming to second question, set is given from 1 to 3, 4, 5, 6. Insert the appropriate symbol belongs to or not belongs to in the blank spaces. It is given first question. 5 is a space A given, but we need to fill this with this epsilon or not epsilon, or simply called as belongs to or not belongs to. That means what belongs to means the element is in the set. Not belongs to means the element is not in the set. 5 is in the set only, that's why we need to write belongs to. 8 is there here? No, not. That's why we have write not belongs to. 0 is there here? No, not there. That's why we have write not belongs to. 4 is there? No, that's why we have write belongs to. 2 is there? Yes, is there? That's why belongs to. Next, 10 is there? Not there. That's why we have write not belongs to. It's very simple. Okay. Coming to next question, third one. Write the following sets in the poster form. First one, A. X such that X is an integer and it is lying between -3 less than X less than 7. This means the value of X is more than -3 but less than 7. Okay? More than -3 means more than -3, what integer will be there? -2, -1, 0, 1, 2, 3, 4, 5, 6 because we have X less than 7. Less than 7 means we have made up to 6 only. Is of -3 less than 6. X means X value is more than -3 but less than 7. That's why from -2 to up to 6 we need to take here. Coming to next one. B. X is a natural number less than 6. It's very easy. Less than 6, what are the natural numbers? 1, 2, 3, 4, 5. Next, coming to third one. X is a 2-digit natural number such that the sum of its digits is 8. What number you are taking 2-digit number? That numbers if we add, we need to get sum is how much? 8. First number, what will take? 70. You have to add, you get 8. 1 plus 7 is 8. Coming to next step, 20 above. 20 above, which is suitable? 26. Next, 30 above, 3, 5. Correct? Next, if you take one more, which one? 44 you can take. Next, 53 we can take. Next, 62 we can take. Next, 71 we can take. And last, 80. But we are not taking 0, 8. Because 8 is a single digit. So I am taking 17, 26, 35, 44, 53, 62, 71, 80. If you add these digits, you get sum is 8. Next, fourth one. X is a prime number which is a divisor of 60. First of all, identify which are divisors of 60. Divisors of 60 is 2, 3, 4, 5. It's all values. Because 2 3s are 6, 6 4s are. How much these all are divisors on values. So the prime integers in these prime numbers, only 2, 3, 5 are the prime. Okay? 60 by 2 is possible, 60 by 3. That means this number is not dividing another values. So this prime values, prime numbers. Only one prime numbers means so many are there now. 2, 3, 4, 5, 12 will get, so many are get. In this prime numbers you get exactly, prime numbers means you get only 2, 3, 5. These 3 only. Remaining also get, you can take 10, you can take 12, like this. Possibilities are there. But in this, 6 also possible. 6 by 60 by 6 divisor. Okay. 6 also we can take. But in this, which one you can take here? You can take 4, 5, 6, like this you can take. But in this, we need prime. Remaining all are not prime. Only 2, 3, 5 are the prime. Remaining we get even numbers only. Even number, except to remaining all even numbers are not prime numbers. That's why prime numbers only, prime divisors what we get here? 2, 3, 5. Divisors are there 2, 3, 4, 5, 6. Like that we will get many. In that we need prime numbers means only will take what? 2, 3 and 5 here are the prime numbers. Next. The set of all letters in the word trigonometry. In this, some letters are repeated. While writing as a set, repeated letters no need to take 2 times, 3 times repeated. No need to write all times. One time is enough. So I also write this one. E is equal to E. I can take T, R, I, G, O, N. Again, one more time, over not required. M, E, T already there, R also there. Next word only Y. Okay? In the repeated letters, we need to take here. Next, F. The set of all letters in the word better. Here also T repeated and E also repeated. One time is enough. B, E, T, R. Enough. Okay, no? Next, fourth question. Write the following sets in the set builder form. The first one, what they given? Set of 3, 6, 9, 12. This is clearly multiples of 2 or 3 more. 3 ones are, 3 twos are, 3 threes are, 3 fours are. Okay? But here multiple of 2 only have 12 only. So I take this set A. Set of elements X. X is equal to 3n, where n is belongs to natural number and n is lying between 1 to 4 only. Natural number compulsory and n is from where to where? 1 to 4 only. 1 substitute 3, 2, 6, 3 means 9, 4 will take means 12 will get. Coming to second question. Second question what? 2, 2 square, 2 cube, 2 power 4, 2 power 5. So power is increasing. Okay, no? Here I make this is set B. It takes x only with capital letters. The element x such that x is equal to 2 power n. But where n is a natural number and n is lying between 1 to 5. Correct? Verified natural number compulsory because if not take natural number, decimals also will include. So 1 to 5 if you take 1, 2 will get 2, 4 will get. If you take 5, 32, like that all numbers will be possible. Coming to the third one. Here what is that? 5, 5 square, 5 cube, 5 power 4. That's why here I take C. X is an element such that this is like the power 5 is increasing. 5 square, 5 cube, 5 power 4. That's why I am writing this one is 5 power n. Where n is clearly natural number. And that number lying between from where to where? 1 to 4 only. Okay? 1 if you take 5 power 1, 5. 2 take 5 square, 25. 3, 5 cube, 125. 4, 5 power 4 is 625. Next, fourth one. Fourth one what? 2, 4, 6. It's clearly multiples of 2. 2 1s are, 2 2s are, 2 3s are, like that. That's why set D is element x such that x is equal to 2n. Where n is nearly natural number. Enough. Because it is a complete of infinity is there. All natural not restricted. 1, 2, 3, next 4 take 8 will get 5, 10 like that. Coming to fifth one. Fifth one, 1 square, 2 square, 3 square, like that, 4 square, 100 means 10 square. So here even numbers power square is there. That's why so he said set of x elements. This is a collection of elements x. What is x here? Is clearly n square. But where n is a natural number, but restricted here from where to where 1 to 10 only, up to 10 square only. That's why the n is from 1 to 10. Next, coming to fifth question. List all the elements of the following sets. List means simply roster form only. Okay. First one, set x such that x is an odd natural numbers. Now, set of all the odd natural numbers means what will take 1, 3, 5, 7 plus and so on to infinity. Coming to next one. X is an integer, but x is lying between minus 1 by 2 less than 9 by 2. That means minus 1 by 2 means what? Minus 0.5 less than x less than 9 by 2 means 4.5. In between this, we will take integers. 0 left side next to minus 0.5 next to minus 1. That's why minus 0.5 less than x is more than this value. That's why what? 0. Next 1, 2, 3, 4 only because 4.6 is clearly less than 4.5. So exactly 4 is the last integer. Next, coming to this. X is an integer, but the given condition what there? X square is less than or equal to 4. Now, take this here, but we get x square minus 4 is less than or equal to 0. X square minus 2 square is less than or equal to 0. This we can write x plus 2 into x minus 2. X plus 2 into x minus 2. A simple meaning here, the value expression is there like this. X square minus a square less than or equal to 0. Then x is lying between from minus a to plus a. Generally. So as for that, here in the place of a, what is there here? 2. So in between minus 2 to plus 2. Meaning of closed bracket understood? Minus a plus a also include square bracket or closed bracket. But we don't want in between minus a plus means we get decimals also. Like that minus 2 to plus 2 we get decimal parts also. But we need only which one? Integers. So between minus 2 to plus 2, which are remaining integers? Minus 1, 0, 1 and 2. Only these are the integers. This formula remember we will discuss again in interval concept in the same chapter. X square minus a square less than or equal to 0 means x value belongs to, that means lying in this interval from minus a to plus a. Minus a plus a also include when you take square bracket. Reason equal to also there. Only less than is there, take only open bracket. Open bracket means these values are not included. Okay, that's why. But we need only integers. That's why I am taking integers in this. So C is only integers means in between minus 2 to plus 2 means minus 2, minus 1, 0 and 1, 2. Okay, so the solution for third one. Coming to fourth one. X is a letter in the word loyal. So very simple. L O Y E. L 2 times repeated, no need to take 2 times. X is a month of year not having 31 days. Which month not having 31 days? That month we need to write here. January having 31 days. February, March also having. Next April, May having 31 days. Next June, July having 31 days. August also having 31 days. Next which one? September. October also having 31 days. Next November. December also 31 days. Not. Next coming F. X is a consonant in the English alphabet. Precedes K. Precedes before K. That letters must be consonants. Vowels are A, E, I, O, U. Preceding means B, C, D, E not possible, F, A, B, C, D, E, F, G, G also not a vowel, is consonant only. Next H, I is not a consonant, is vowel. Last one what? G. That's all. These are the letters precedes K and those letters are consonant letters.